Example number 2. 2y primes times natural log x plus y over x equals to y to the minus 1 times cos x. Solution. It's a perfect Bernoulli's differential equation. From a standard form of Bernoulli's equation, you can put y prime here. So y to the minus 1 is actually y to the n here. Step 1. To reduce the equation into standard linear form. This is the first thing that we do here. So let me do the process to change it into linear form. Divide both sides by y to the minus 1 to have y times y prime plus y to the 2 over 2x times natural log x equals to cos x over 2 natural log x. Let's suppose y to the 2 equals to z. Take derivative on both sides. Z prime equals to 2y times y prime. Y prime is because of chain rule. After separating the variables, I have now y times y prime equals to z prime over 2. Just replace y times y prime by z prime over 2 here. And obviously y to the 2 by 1. Multiply both sides by 2. To have z prime plus z times 1 over x natural log x equals to cos x over natural log x. And now I got the linear differential equation. This is a linear differential equation. It is no more non-linear. Compare it with the standard form of linear equation. This is derivative term, and p of x is 1 over x times natural log x. Q of x is cos x over natural log x. Step 2. To find the integral factor. Integral factor equals to e to the integral of p of x dx. Substitute the value of p of x, which is 1 over x natural log x. Can I write 1 over x natural log x equals to 1 over x or natural log x? Yes, I can. How I can change 1 over x natural log x to 1 over x or natural log x? Let me do here. 1 over x natural log x equals to 1 over x or natural log x. How we can prove that? Equals to 1 over x or natural log x or 1. If I write 1 under natural log x, so to change it into product form, this natural log x or 1 will flip in the opposite way. I can write 1 over x times 1 over natural log x. So that's how it equals to 1 over x natural log x. So that's how it equals to 1 over x natural log x. It's simple as that. E to the integral of 1 over x or natural log x equals to e to the natural log x times natural log x. There is a simple logarithmic rule. This base e will cancel with the natural log x, and we're only left with natural log x. So here is the final value for integral factor I equals to natural log x. Step 3. To find the general solution, which is y equals to 1 over integral factor times integral of integral factor times q of x dx plus c. Since we have supposed z variable for the y, and therefore it is better to write z equals to 1 over integral factor times integral of integral factor times q of x dx plus c. Substitute the value of integral factor, which is natural log x. Yeah, natural log x is the integral factor that we got in step 1. And obviously q of x is cos x or natural log x. This natural log x will cancel with the natural log x, and we're left with the integral of cos x dx only. After integration, I have now z equals to 1 over natural log x times sin x plus c, because the integration of cos x is sin x. Now I want to substitute back the value of y for z, which was supposed in step 1. So just replace z by y square. Take under the root on both sides. And this is the final answer for the general solution, which is y equals to 1 over natural log x times sin x plus c.